Alright, so let's continue on using our log rules here to solve a couple of simple equations involving logarithms. A couple of actually very simple logarithmic equations. We're going to look at this in a little more depth in section 6, but here's just a couple basic ones to get us the idea. So using our rules for logarithms, we can simplify these expressions down so that we'll actually be able to solve these equations. For example, here on this one on the left, says log base 2 of 10 plus log base 2 of 3 is equal to log base 2 of x. Well, we have like bases here on the left side, and we know that if we have like bases that are being added, we can actually multiply those powers, 10 and 3, using the product rule. The product rule says if we multiply like bases, we would add the powers. That's what's happening here. So we know that the log base 2 of 10 times 3 would be equal to log base 2 of x. Well, 10 times 3 is 30, so that would give us log base 2 of 30 equals log base 2 of x. And hopefully it's intuitively obvious that if we have two logs with the same basis set equal to each other, then their powers would have to be equal to each other. And we can simply say 30 is equal to x. And there it is. So that's a really simple logarithmic equation where we have a variable inside the log. Again, section 6 will be in greater depth on how to, section 7, what we'll do next, we'll go into greater depth on how we can do that. But that's the basic idea here. Once we get logs with the same basis equal to each other, we can just set the powers equal. So we'll do one more here on the right. Feel free to pause it and go ahead and work through that on your own if you want a little extra practice. But this is very, very similar, except we can do one extra step first. We notice we have a coefficient of 2 on this log x, which means that by the power rule, we can move that to the squared position. So it's really log of x squared plus log 7 equal to log 28. Now, this doesn't have any bases written here, so we know that if it has no base, this really is the common logarithm, which again means base 10. Which is actually not going to be relevant here. It could be any base. The way we're going to do it would work the same no matter what the base was. So we have log x squared plus log 7 on the left. They have the same base, that base of 10, which means I can again apply the product rule. So x squared and 7 are going to be multiplied together. So I'll write it as 7x squared. And we know that would be equal to log 28. Well, here we go. We have two different logs on opposite sides of the equation, but they have the same base, which means that we know that the powers are equal to each other. And then we could solve this equation from here using our basic inverse operations. So we know x squared would be equal to 4. Then when I take the square root, I'll get x equals to 2. Now, we know that if we're solving an equation and we introduce the square root, that we need to make sure we account for plus or minus. However, since we know that x is going into a logarithm, we don't need x equals negative 2 because it's inside of that logarithm. Right? And we talked about this briefly in a previous section that the domain for log functions is positive values. We can't plug in negative values into a logarithm, into the power for a logarithm. So we only need to worry about x equals positive 2 in this particular case. We can ignore x equals negative 2. So there's a little bit of a taste of how we can use, how we can solve basic logarithmic equations. All right.